Hi, this is Tim. Today we're going to have a look inside of a three-phase motor, and we're also going to talk about how it creates a rotating magnetic field, or at least the appearance of one, using the cheapest compass we could find. Please take a moment to like this video and subscribe to our channel. We put out at least one automation video a week. This is a little bit different than we normally do, but we've been doing some motor lessons here recently and they've gone really well. So if you have any questions, put them down in the comments and we'll see what we can do as far as answering them. As we talked about in a previous video, your three phases are 120 degrees apart, and as they rise and fall in a sine wave, they do create this rotating magnetic field. Also, I need to give credit, Electroboom, this is actually his idea. I got it out of one of his videos. But somebody wrote me like a 2-page comment about how I was wrong about there being magnetic fields rotating. And I'm sure this guy's smart and knows a lot of math and things like that, but from the perspective of troubleshooting machines, it does have a rotating magnetic field. So for this video, we are using parts out of one of our trainers. Please don't do this to your trainer because I dropped a part on the floor, so I doubt I'm gonna be able to get my motor back together. But it does look exactly the same as our single phase one that we looked really closely at, but there are 3 sets of windings in this. And in the end, it looks like this. So we have L1, L2, L3, and they all have that sine wave offset 120 degrees. Again, I have a video already that kind of goes through this, so I'll put it in the description. Today, what I really want to show you is that through these 3 sine waves, the sum of their magnetic pull, we'll say, rotates through here. And you can see that with a compass and a motor. Now, there's very few setups that will actually do this because I actually tried it on several motors. And the issue is when you have a motor this big, your compass actually needs to be about that big. So I finally found that this trainer motor and this compass set on top of it did work. So again, guys, please don't do this to your trainer. We are using the PowerFlex 525 drive on it to make our 3-phase signal and also to slow it down enough that you can see it rotating. And this is the windings out of our motor. Also, I don't think I showed this earlier, here's the armature out of it, and really this one appears to be mainly a chunk of aluminum, and it does have these spiral cuts in it. Now we're going to hit the start button on our PowerFlex drive, and you're going to see the compass start rotating. We can hit the reverse button on our drive, and the compass will start rotating the other way. So yes, while I get that this one is push pulling, push pulling, push pulling, and this one is push pulling, push pulling, push pulling, and this one is push pulling, push pulling as that sine wave goes up and down. By them being offset 120 degrees, it makes the intensity of that push and pull rotate with a 3-phase motor. So I do have to say that yes, the rotation of magnetic fields is what makes the motor turn. Also, it's just good to make sure that everybody does understand when you're dealing with an AC motor, there is actually nothing, power's off. There is actually nothing that touches on them. So we have these windings here and we have this piece here, but they slide together and don't actually touch or anything. So I hope this video has been helpful. I'm gonna crawl on the floor and see if I can find the piece that I dropped. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!